So in the previous session, we have built out two different machine learning models, that is random forest classifier and a logistic regression, and we achieved a pretty decent accuracy values, that is 73% and 74% respectively. Let's have a look at or build out the next type of model, that is deep learning model. So this is our focus when it comes to learning a deep learning model, right? So we'll try to apply all the concept which we have learned in the deep learning module basically. Okay. So first, the first thing what I am going to do is basically convert the numerical values, or I am going to label the data basically in order to make the classification or deep learning model effective. I am going to label the data. So all the ratings which comes under less than 4, I am going to mark it as not happy. That is, rating equals to 1, 2 and 3 will be marked as not happy, and 4 and 5 will be marked as happy. So that's what the two labels which I have defined. So I'm going to go ahead and do that. So df sentiment equals to df review rating less than 4. So I am going to label that on this particular two label categories. So first I am going to split the data again. So test training text, training y and test y. So train test split, this is the same method I am going to use, and instead of that numerical parameters I am going to pass this df or review and df sentiment. So now that I am done with the splitting of the data, it's time to uh, convert the data, basically the textual data, into numerical forms, right? Either in a vectorical form or in a tensor form, what we can say. So first, we'll make the algorithm understand that this is the string type, what the data is available. So text train equals to the text train or a train text dot as type of string, even the text as a string. So once that is done, we have to finalize or vectorize the data, right? So I'm going to use a tensors, or I'm going to convert the textual data into tensor. So for that, what I'm going to use, I'm going to use a tokenizer. So this tokenizer will convert or break the sentences into individual tokens, right? So that's what the tokenizer will do. So within that, NB words equals to max NB words. What does this mean? The maximum words it has to split at a time. This tokenizer has to split the words maximum up to 20,000 words. So I am going to convert these tokens into a 2D integer tensor at a character, not at a character level, at a word level. So that's why character level equals to false. So once I have tokenized the word, I have to fit that fit this tokenizer on our training data. So for that, tokenizer dot fit on text, I am going to pass the training text. So once the training text is available in the form of tokens, I am going to use a method called text to sequence. So text to sequence will internally convert each and every token into some numerical representation that is unknown. Actually, it will assign some numerical value or a tensor value for particular word it has seen, but that particular tensor is common for that particular word throughout the text corpus. So for example, I have if it has encountered a word called awesome, suppose if it assigns a certain numerical value for that awesome, that numerical value will remain same throughout the text corpus. So I am using that method to convert the textual data into numerical value, or basically 2D tensor. Similarly, I am storing that as a sequences. Similarly, I'm going to apply for the text data as well. So tokenizer dot text to sequence, and I'm going to pass the text underscore text. So now that I have converted the textual data, let me have a look at how many individual or unique tensors it has been generated when I do this. So for that, what I am going to do, I am taking a word index. So tokenizer.word index will actually count the unique tokens generated. So this tokenizer equals to tokenizer, or the function which we have defined here, it will be generating the unique tokens basically. So that's why when I get a count of it, I have found that the unique tokens generated by the tokenizer function is around 28,411 unique tokens. So now that I am available with the sequences or the tensors, it's time to do certain padding around that. So pad sequences are used to bring all the sentences to the same size. So since we have seen that each and every sentence are not at a same length, right? One sentence would be around word length of 21, and other sentence is around word length of about 9 or 10. So to make it one length common, or to make the input size or input matrix size as a common for basically for deep learning models, we have to pad the sequences. So for that, what I am going to do, I am going to use a method called pad sequence, which is available in the keras module. So you can just, I have just imported in the above session already, so you can just use that pad sequences. I am going to pass the training sequences, that is which I have generated over here. So max length equals to max sequence length. So I have fixed the max sequence length, or the max tensor length has 200, and I am going to keep this even similar for the test sequences as well. So x test equals to pad sequence, and sequence test, and max length equals to max length. So now that I have padded the tensors, you could just see that even though the number of rows are different, the column size is 200. So that's what we have done for the tensors. So we basically padded the each and every sentence with the padding basically. So what does this padding do? Suppose if I have taken a very first sentence with 21 words, if the next sentence has very less number of words, say 10, it will import or implicate zeros in place of empty values, and make that 10 text or a 10 word length as 00000 and the actual words. So again the whole sentence will be now with the length of 20 again. So this applies to all the sentences. So now that I have converted the data into padding sequences, or padded tensors, now it's time to feed the sequences into the deep learning model. So for that, I have just defined a model equals to sequential, because I am going to feed the data in a sequences, right? Sequential format. So that's why I am going to define that model as sequential. That sequential is not only about the data type that I am going to input, but it also incur that I am going to add more and more layers in a sequential manner. So starting from the input layer to the output layer, I am going to process the data sequentially. So while building the layers, so you can just see I have started with the model.add layer with the embeddings of 120 neurons basically. So 128 neurons in the very first layer, that is embedded layer. Uh, then I am going to add a layer of LSTM, that is long short term layer, with the same 128 neurons. Dropouts as zero point 0.2, that is we have studied what dropout is. Then recurrent dropouts as zero point 0.2. In order to this actually stabilizes or drops certain unwanted neurons which are not used, or it will randomly drops the unwanted neurons in every layer, layer by layer. So then I have added the input shape. The shape should be one comma. So what should be the output layer basically? So one comma, that's it. So then I have added a final output layer, and I have also mentioned that it has a dense. So what does this dense indicates? I am going to build a neural network which is densely connected. What does the term dense means? Each and every neuron of a layer 1 is connected to each and every other neuron in the subsequent layer. So that is what the dense term defines. So I have since I am going to add a one particular output, so I wanted one particular output at the end of the neural network. So if I pass a sentence, I don't want how much it is a positive sentence, how much it is a negative sentence. No, I don't want thing. So I just want one particular output, right? So I don't want multiple outputs basically. So that's why I am setting the neuron at the output layer as one. Then the activation function to suit this particular thing would be sigmoid, right? Sigmoid is the activation function which I have used. So now we have defined or structurized our neural network. Now it's time to compile the neural network. So within the compilation, I'm going to add three other different parameters. So one of that would be, so what are these parameters basically? So the very first thing is the loss, that is binary cross entropy. So this cross entropy is a method which monitors the loss function basically. So the loss function which I have defined is the binary cross entropy. Then an optimizer. I have chosen the optimizer as Adam. There are a number of optimizers which are available in the field of deep learning. So you can just visit this link which I have dropped it over here to suit the you can select any optimizer to the particular problem. So then I have added metrics as accuracy. So the monitoring fact or monitoring metrics which I am going to implement is the accuracy. So now I have built the structure of the neural network, compiled the structure of the neural network. It's time to fit the data into this built out neural network. So for that, I am going to fit model.fit as x train and train y. Then batch size, I'm going to implement a batch size or a batch training of 128. Then epochs, only one epoch I'm going to run it for. And you can run it for multiple epochs like 10, 20, 30, depending on the uh, space available or the time available. So for example, I have been running this into one epoch right now. So then the validation data on which the validation score or this particular loss function should apply on the X test and test Y data, right? So this is the basically evaluation metrics which I'm going to use. That's why the validation data equals to X test and the Y test. So when I run this, you can just see it has run for one particular epoch. It has trained on 56,752 samples, and it has validated on 14,189 samples. That is the training data is the value which is over here, and the tested data is the one displayed over here. So since I have mentioned the epoch as one, so it has run for only one epoch, and you can just see that it has given me the accuracy of 90.5%. So it is very, very massive when compared to our traditional machine learning techniques, right? So it has yielded me 74% for logistic and 73 for random forest. But clearly you could see this deep learning model has outrated all the things, right? All the classic machine learning models. So it has given me the accuracy of 90.5% and validation accuracy of about 91.83%. So this is a very good model which we have just built out in order to classify the sentiment or in order to identify the sentiment of the input text. So if you just pass any textual data to this particular model, it could able to classify it into positive, negative, and neutral. But here only a positive and a negative sentiment with an accuracy of 90.50. So this comes to an end of our whole process of building a sentiment analyzer. Thank you.